Hi, good morning, and welcome to HVAC 111, Basic Electricity and Technology Processes. Today, we are going to discuss about a topic from Unit 4, Basic Electrical Circuit Laws. For this session, we are specifically going to tackle about Ohm's Law. At the end of this lesson, you are able to define Ohm's law, discuss the relationship between resistance, voltage, and current in an electrical circuit, and finally, solve mathematical problems in relation to Ohm's law. So let's get right to it. Ohm's law is the relationship between current, voltage, and resistance in an electrical circuit. It was discovered by George Simon Ohm and was published in 1827. Ohm's law mainly involves current, voltage, and resistance in an electrical circuit. So let us define what is current, voltage, and resistance. Current is the continuous movement of electric charge through the conductors of a circuit. It is often referred to in terms of flow, just like the flow of a liquid through a hollow pipe. Current is represented by the symbol I and has a unit of ampere. On the other hand, the force motivating charge carriers to flow in a circuit is called voltage. Voltage is a specific measure of potential energy that is always relative between 2 points. It is referred to in terms of the energy pushing the electric current to flow in an electrical circuit. It is represented by the symbol E and has a unit of volts. Meanwhile, current tends to move through the conductors with some degree of friction or opposition to motion. This opposition to motion is more properly called resistance. Resistance is simply the ability of the device to resist the electric charge flow. Resistance is represented by the symbol R and has a unit of the capital Greek letter ohm. Now that you know the definition of current, resistance, and voltage, let us review the standard units of measurement for electrical current, voltage, and resistance. Current is represented by the symbol I and has a unit of ampere, or A. Voltage is represented by the symbol E and has a unit of volts, or V. And resistance is represented by the symbol R and has a unit of ohm, the capital Greek letter, or the horseshoe symbol. Now that you are familiar with the symbols and standard unit of measurements of current, voltage, and resistance, let us now proceed to the Ohm's law equation. To easily remember the Ohm's law equation, it is usually represented by the circle technique or the triangle technique. For this session, we are going to utilize the Ohm's law triangle technique. It is a very simple and useful tool for analyzing electric circuits. The trick is to draw a triangle shape and arrange the letters E, I, and R inside the triangle. E at the top, I on the left, and R on the right. Once again, E is for voltage, I is for current, and R is for resistance. If you know, or if the values of E and I are given, and you wish to determine R, just eliminate R from the picture and see what's left. So, eliminate R. What's left is E over I, or voltage divided by current. On the other hand, if E and R values are given and you wish to determine I, eliminate I and see what's left. So, eliminate I. What's left is E over R, or voltage divided by resistance. Lastly, if the values of I and R are given and you wish to determine E, eliminate E and see what's left. Now, eliminate E. Hence, what's left are I and R, or current times resistance. Now that you are familiar with the Ohm's law equation, let us try analyzing simple circuits with Ohm's law. Let's see how these equations might work to help us analyze simple circuits. We have here a circuit that has only one source of voltage, the battery on the left, and only one source of resistance to current, the lamp on the right. This makes it very easy to apply Ohm's law. If we know the values of any two of the three quantities, either voltage, current, or resistance in this circuit, we can use Ohm's law to determine the third. In this first example, we will calculate the amount of current in a circuit given values of voltage and resistance. The battery, which is the source of the voltage, is equal to 12 volts, or E is equal to 12 volts. While the lamp, which indicates the resistance, has a value of 3 ohms, or R is equal to 3 ohms. Now determine the amount of current in this circuit. Now, using the Ohm's law triangle technique, we are going to find for I. Hence, eliminate I. And the values or the symbol that remains are E and R, or E over R, which represents that voltage is divided by resistance to get the current. Now, substitute the values of voltage and resistance. E, or voltage, is equal to 12 volts, divided by R, or resistance, is equal to 3 ohms. Now, proceed with the mathematical operation. 12 divided by 3 is equal to 4. And then, apply the standard unit for current, which is ampere, or A. Therefore, for a circuit with a voltage of 12 volts and a lamp with a resistance of 3 ohms, the current is equal to 4 amperes. So, to find the current, or I, divide voltage with resistance, or E divided by R, and then substitute the values. 12 volts divided by 3 ohms, and then you will have the answer 4 amperes. For the second example, you are going to calculate the amount of resistance in a circuit given the values of voltage and current as indicated here. What is the amount of resistance offered by the lamp if the voltage is equal to 36 volts and current is equal to 4 amperes? This time, solve this example by yourself. Pause this video and try to find or determine the resistance of the given circuit. Now let us check if you got the correct answer. So, to determine the resistance, let us make use of the Ohm's law triangle technique. Since resistance is the problem, eliminate R and write the remaining symbols, which is voltage or E over current or I. Then, substitute the values. E is 36 volts and I is 4 amperes. Then proceed to the mathematical operation. 36 divided by 4 is equals to 9. And apply the standard unit for resistance, which is ohms. Therefore, if voltage is equals to 36 volts and current is equals to 4 amperes, 36 volts divided by 4 amperes is equal to 9 ohms. If you got 9 ohms as your answer, that is the correct answer. Very well, keep it up. Now let's proceed to the last example. In the last example, we will calculate the amount of voltage supplied by a battery given values of current and resistance as indicated here. What is the amount of voltage provided by the battery? Once again, pause this video and solve the problem by yourself. Let us check if your answer is correct. So, to determine for E or voltage, let us use once again the Ohm's law triangle technique. Since voltage is to be determined, eliminate E and write the remaining symbols, which are I and R, or current times resistance. Then substitute the values. 2 amperes times 7 ohms. And proceed with the mathematical operation. 2 times 7 is equal to 14. And apply the standard unit of measurement for voltage, which is volts. Therefore, for an electrical circuit with a current of 2 amperes and a lamp having 7 ohms resistance, will have a voltage of 14 volts. Congratulations! You are now ready to proceed with our exercises. So that's all for this session. Thank you for listening and have a good day.